So I'm here today to talk to you about server-side rendering web components, and we're going to get into that. Unfortunately, we're going to have to do some background information first in order to get to there, but we'll build up to it. As John said, I'm Simon MacDonald. I am the head of developer experience at Begin. If you need to get in touch with me after this talk, please hit me up at Mastodon. That's the link for my Mastodon account. You could probably find me on Twitter. I still have a Twitter account, but it's getting scary over there, so Mastodon's probably the best way to get a hold of me. Anywho, I'm going to start off my talk by asking a very silly question. Have you ever had a dependency break on you? Okay. Yeah, it's kind of a stupid question. I mean, dependencies are unstable and they can be a time sink, and this kind of unplanned work keeps you from iterating on your product, and it's really frustrating. I realized when I was putting together this slide that I was thinking that Office Space came out in like 2006 or 2007, but in actuality, it was 1999, and that was, I checked my math, 23 years ago, which is kind of scary. So some of you may not know about this movie or may not even been born then, which is kind of scary to me. But it's a classic movie about tech workers in a cube farm. And if you get nothing else out of this talk, at least you got one really good movie recommendation. So try and remember that. There's a really good quote here from Jeff Bezos, and people ask him all the time, what's going to change in the next 10 years? How do we prepare for this stuff? But the thing that they rarely ask is what's not going to change in 10 years? What's going to be stable? And he thinks that the second question is way more important, because the things that are stable, you can build a business, you can build a strategy around. And I would argue the same thing. It's way easier to predict the things that aren't going to change over the next couple of years. And that's what you can really use to build your business on top of. Why do we want to build businesses on top of things that don't change? Well, it's because, software is really complicated. And it is certainly not made less complicated by adding a lot of dependencies to your software. Arguably, it's made way worse because these dependencies often conflict with one another, and that can be a huge pain. Now, we've seen this kind of thrash before. Web browsers used to be very broken. The browser ecosystem used to change all of the time. It was not uncommon for these different browsers to interpret capabilities differently, and therefore they would break different websites. You know what? I'm looking at this slide here. It's a little bit out of date, so let me just fix it really quick. Okay, that's a little bit more accurate, even though Apple is making a lot of noise about 2023 being the year of Safari, and I really hope that they do fix a lot of things in their browser, but I'm a little skeptical because they do have a monetary reason not to make their web browser better, but we have hope. But web browsers really don't break. When it comes down to it, the web standards that we have evolved to now give you consistent behavior right across a bunch of different browsers, as long as those standards are implemented, which they are in most cases. And the browsers automatically update themselves so that they are evergreen. You never have to worry about them being terribly behind. And in order to remain competitive in the browser marketplace, they have to maintain this backwards compatibility. So you know that these things are going to be working at all times. So web browsers are backwards compatible, eh? So, in case you didn't notice, I'm Canadian. I was really going to prove it. I think there's a lot of Canadians here today, which is great. We're infiltrating everywhere. Anyway, what we really mean by this backwards compatibility is that if you look at sites and code that were written over 25 years ago, you'll see that they still work perfectly well in today's modern browsers. One example of this is jQuery. So jQuery was used in many, many sites in order to, smooth over a lot of the differences that existed in these browsers. And over time, as the browsers became more and more standard compliant, we didn't really need jQuery anymore. So we were able to drop that functionality and use what was in the platform. But if you have a site that was written in 2003, it'll still work, even with an old version of jQuery, because the browsers will take care of that for you. So we have to ask ourselves, if the browsers can be that stable, can our own source code be that stable as well? And I would posit that breaking changes are optional. Unfortunately, we tend to eagerly opt into them. Just because you're picking a framework that compiles to a web standard, it doesn't mean that you're enjoying those web standards. So you might want to think about that just a little bit more. So when it comes to changes, there's, two kinds of change. And of course, the answer to my previous question is, yeah, of course, we can opt into things so that our source code doesn't break and it's very stable. But there are two kinds of changes that we have to look out for. The first, the bad one, is breaking changes. That's when we see the removal of APIs or interfaces or behaviors. And then, of course, in some cases, if you're removing something because it's a security issue, then that makes perfect sense to get rid of it. But a lot of times, there's breaking changes are for the sake of being a breaking change. Many times, the package is handling things using Semver correctly. Updating a major, introducing breaking changes is good. Updating a minor or a patch and introducing major changes is bad, because that is not the way that is supposed to work. Those of us that have been around long enough probably remember the giant breaking change from going from Angular 1 to 2. It was a complete rewrite of your application. And then they did it to us again in a later version of Angular. And I think a lot of people were, burnt too many times there and moved on to other platforms. React 18 has some breaking changes in it as well. It's handling it quite well because it's breaking things on a major. One of these things includes the way that they do updates. They're batched now. And of course, TypeScript 4.8, which is a minor update, also includes breaking changes, which is not really what you want to see. You want those changes to be introduced on majors. So if you're generally following Semver and you're seeing like, oh, TypeScript 4.8 is out, I'll just upgrade it because it's only a minor change. It shouldn't have any breaking issues. And there you go. It introduces breaking changes on you, and you've got a whole bunch of unplanned work because of it. So you really want to pick dependencies and frameworks that properly handle these changes for you and make sure that they're using Semver properly. The other kind of change, or the good change, is the additive change, and it's just that it adds new functionality without removing any of the old stuff. So the change from HTTP 1 to 2 is great. It gives us new capabilities, but doesn't break any of the old protocol. When we were back doing XML HTTP requests, our AJAX stuff, and that was like a pretty good API to start with, but we refined it into fetch, and that's a much better API for developer ergonomics. And of course, we've added things like async await, which you can use or not use. You can still do callbacks if you want to. You can still use promises. But if you want to write kind of code that is using async await, you can do that. When we're adding the module type of a script in as well, instead of just using the old standard script tag, we're able to tell people that this is like a new ES module instead of the standard JavaScript thing. Anyway, these are all examples of additive changes that have been added into the platform without breaking anything else, and that's just great. Now, the front end itself is also very, very complicated. The front end is this vast ecosystem that has many compatibility problems. So it's very common for you to transpile code, but those subtle differences between the code that you write and the code that is actually run can cause unexpected breakages, which is very frustrating. Taking a look at these templating systems. So earlier versions of JavaScript didn't have the string template literal concept. So we took a page from other runtimes like Java or Ruby or Python, and we created these templating languages. So it's like embedding a smaller language into your bigger language. And sometimes that makes the syntax really hard to read because it's not very standard. It's not actually JavaScript in this situation. And then we have other things like non-standard dialects. JSX is not JavaScript. It looks like JavaScript. It kind of acts like JavaScript, but you can't run that directly in a browser. You have to do a transpilation step in order for JSX to actually be executed in the browser. So the code that you write and the code that you run in this situation is very different again. And then another way of doing things is introducing a completely new programming language and then using it to compile down to web standards. So that's the thinking behind Svelte. And it has all the same problems of a templating language. It's like HTML, it's like JavaScript, but it really isn't. Now, you have to give credit to Svelte because they are very upfront with this being a non-standard dialect. And, they stand by the idea that a compiler is a better solution because it can admit more efficient code. Okay, let's take a look at some of the compilers. All right. The problem with transpilers is that they obfuscated the runtime code. It's bad and it gets worse. So, you take a look at this code example. That's not very readable. Any kind of bug in this will be extremely hard to diagnose. You're not sure where things are coming from because this isn't the code you wrote. It has no bearing on the code that you actually wrote. Now, a 12,000 line of code, file is totally normal for a trivial bundle. And that's not very efficient, and it's really terrible developer experience for you to debug. Lots of people will think that, object source maps will fix this problem, but quite often they don't work. And especially when you're, doing things in an environment like Node.js, which is not built for this type of thing. And then, of course, when you introduce something like a transpilation step, do you even really know what your tools are doing? You're really just counting on them to do the right thing for you. So let me give you an example of something that I recently came across when inspecting an application. This one-liner, which I think was something like 295 or 296 bytes, very small, completely separate JavaScript file. And as best as I can tell, what it does is adds in this method called toLower, which just calls toLowerCase. How is that optimizing code for you? Why is that better? I don't understand. It saves me typing 4 characters, but I would argue that having to go through this every time I need to call something that is in the platform is probably a bad idea. That's going to add overhead. Anyway, so check what your tools are doing, folks. Now, static is not equal to dynamic. Earlier today, Henri talked about, some metrics like first contentful paint and time to interactive. And some of these metrics can be absolutely terrible when we're using our giant frameworks, because what's happening is we're having to send JavaScript down to the browser in order to be able to create the user interface, which then makes API calls to the backend in order to populate the interface with the data. And so that's really going to impact your first contentful paint, your time to interaction. So you really want to look at something like that. Is that really the right way to do things? I would argue that in today's modern JavaScript environment, we have way too many moving parts. What can we get rid of? Can we simplify this situation? What are the root causes of the complexity? How do we avoid this kind of stuff? And, one of the ways that we can avoid this is by going back to the way web pages and websites were previously written. And we have a new case for progressive enhancement. Progressive enhancement is not new. People have been doing it for a very long time. At some point in time, it ran out of fashion. And, I love the JavaScript community. It helped me not buy this house, but put a pretty good down payment on it. But it does get to be a bit fashiony sometimes. And progressive enhancement went out of style. But we really should bring it back and think about it more, because there are many reasons. First, the ethical reason for inclusivity. We want as many people as possible to be using our websites and applications. And when you build with progressive enhancement, when you start with a working HTML format, it is the most accessible application that you could start with. Now, of course, there's also business reasons as well, if you need to make that argument. The bigger your audience, the more devices, the more people who can use it, the more money that they will generally spend on your products or services. And then there's the selfish developer reason as well. I hate fixing broken stuff. I like it when stuff works. So if I have some way that it's going to work for, screen readers, it's going to work for old web browsers, it's going to work for the evergreen web browsers, it's going to work, on some sort of new device that's coming out that is a virtual voice assistant or something like that, all because we're using progressive enhancement techniques, that's what I want, because I will be able to spend more time working on the product, adding new functionality that makes my customers happy instead of chasing a bunch of breaking changes. So with progressive enhancement, you start with working HTML using, standard anchors, forms, and then you make it better by adding JavaScript to it. It's not the other way around. It's not you start with a bunch of JavaScript and you see where the JavaScript fails, and then you make sure that the failure case is still kind of workable. That's graceful degradation. Progressive enhancement, in my opinion, is way better than graceful degradation. And also, when we talk about doing HTML first, we're not talking about HTML only. It means that the JavaScript comes second in your application, because that's how web browsers actually work. I mean, if you open up any site and you grab your inspector and go to the network tab, the first thing that's loaded is your JavaScript, and your JavaScript gets, or sorry, I really screwed up there. The first thing that gets loaded is your HTML. And then your HTML is used to structure the page. And then after your HTML and your CSS are loaded, then the JavaScript is loaded. And that just makes your page better. It gives it more interactivity. But it should be a sprinkling of JavaScript, not a tsunami of JavaScript. That will make your life a lot better. Now, there's a lot of next generation front-end frameworks that are HTML first. 11D, which I think there is a talk on tomorrow, Remix, Astro, all of these frameworks are looking at doing HTML first. And I would say that HTML first is kind of the new marketing way of saying progressive enhancement, because as I mentioned earlier, somehow progressive enhancement got a bad reputation. It went out of style, not that it ever should have. So you could look at any of these frameworks and see how they're doing things as well. For us at Begin, we've had this open source project since 2017. We've had tens of thousands of apps built on top of it, and Architect has always been HTML first. So we were building our applications just using cloud functions to output HTML coming directly from the server. So everything that came down from the server was working HTML, and then we would enhance it with JavaScript on the client side. So we've been doing this for at least 5, almost 6 years now. And some of the things that we learned about that and kind of inferred what we would be doing later with the enhanced framework, which I will talk about shortly. So what if the entire backend was just pure cloud functions? So Architect, the open source project, is mostly concerned with the backend. So it's responsible for saying, like, instead of load balancing a whole bunch of web servers, let's just make all of the backend things like small cloud functions that we can manage using Architect. It's been working pretty amazing so far. Now, with the modern JS ecosystem, we've got some major problems. First, it's brittle. You got these ecosystems that are incompatible with each other, and they often are failing. We also have these non-standard template libraries, or worse, some sort of opaque programming languages that we have to add on top of things, adding more complexity onto building web applications. And quite often they are static, so not dynamic. You're not getting the content that the user is wanting for right from the very beginning. And it results in all of these kind of, spinners and skeleton screens and really bad metrics on your time to first interaction. So can our front-end source be pure standard-based HTML, CSS, and JavaScript? So what if instead of learning a non-standard programming language like, JSX, and compiling it into JavaScript, we start it with web standards? Let's start with some very basic primitives and get things working incrementally. Let's pick HTML and CSS. We'll start with that from the very beginning. And then we take those Legos and we stack them up and we build bigger and better things. And once we've got it all working, we can start to add client-side JavaScript for the more enhanced browser behavior. In other words, what I'm really trying to say is use the platform. I mean, like I said earlier, back in the day, we used to use jQuery for everything, but now we rarely need to reach for it, since the most important parts of jQuery have become part of the platform. I mean, it made it so much easier to do query selectors in jQuery, but I mean, now we have query selector all built into the platform, and it's because of the popularity of jQuery that we have those things. So it's the same thing with some of our modern JavaScript frameworks that we use to build reusable component user interfaces. We've popularized a lot of them, but is there something in the platform that we can use today that will reduce our dependencies on some of those frameworks? And, the answer is yes, of course there is. We have web components. And web components is a suite of different technologies that allows you to create reusable custom elements and utilize them in your web applications. So these custom elements are all encapsulated away from the rest of your code. So all of the styling and the behavior can be, just encapsulated into a single file so that you can reuse it in different projects and it doesn't affect other parts of your application as well. There's three main specifications that are used when you're building web components. The first is the custom elements. It basically allows you to define a new tag that represents your reusable component. We have the shadow DOM, which allows you to encapsulate your styles and your DOM away from the rest of your application so that it doesn't affect things. And we use things like slots and templates in order to be able to compose components out of other components. So you can really get granular and have some very small leaf components that you build up together into a giant tree. So web components are, amazingly enough, I think somebody said earlier today that React is about to have its 10th birthday in mid 2023. Well, Web Components has already had its 10th birthday because it's been out since 2012. The difference is it was an evolving standard, and for many years I wouldn't say that it was ready for prime time, but we've really reached a point now where web components are available across all of the evergreen browsers, and there's no reason not to use them right now. So if you can use a web component and get rid of some of the large JavaScript frameworks that you're using in order to build UIs right now, you should probably take a look at doing something like that. Now, the thing is, they have problems. All solutions, have problems. And a couple of the things that you will notice with web components, if you are starting to use them, is that they kind of break progressive enhancement. Unfortunately, when you set up a web component, you're using JavaScript to define it. You have to call the custom element define in order to register your component with the browser. So if JavaScript fails for any reason, and believe me, there's a lot of reasons that JavaScript may fail. And it's not because somebody has just decided to turn it off because they feel like being a jerk and breaking the world. There's lots of network issues. There's DNS things. There's, ever been in a network and ever been in an airport and tried to do anything with the way that everything runs through their captive portal, just messing stuff up? There's lots of good reasons why JavaScript may run into issues. So this is a problem with web components, because if you don't have JavaScript, you're not going to be able to instantiate that web component, and the browser won't know what to do with the custom tag that you're giving it. And the other thing is, again, the way that browsers work is first you load the HTML, you load the CSS, then the JavaScript. So if you have a tag there that is your custom element, it is your web component, until that JavaScript is loaded and parsed and executed, it won't know how to display that custom element. So you'll get this kind of white box, and then it will flash into what it actually should look like. And that's called the flash of unstyled custom element. So those are a couple of things that you have to be aware of when you're dealing with web components, that there are common problems. So I wouldn't bring these up if I didn't have a solution for them. So Enhance is an HTML framework. It's another open source project that we work on and begin. It allows you to author your pages in HTML, use generally available web standards like, web components in order to build your UIs, and then progressively enhance that working HTML with some client-side JavaScript to make everything better. So the fun thing about Enhance is that we're going to be able to, you write your web component as a pure cloud function using Enhance, and then it is expanded on the server. So we'll go through and figure out what actually needs to be as part of the web component, send it down the wire so that when the initial HTML is loaded for the browser, that custom element, we don't have to worry about the define thing, because all of the HTML inside it is already expanded. So it gets rid of that issue. If JavaScript fails, you don't have the custom element define. It also gets rid of the flash of unstyled custom element because your initial HTML is already there for you. It also allows you to do kind of that personalization on the server where you send all of the data down immediately so that, hey, if I'm logging in and it's Simon MacDonald, I'm going to see what my to-dos are. I'm going to see what, the weather is for my particular area because I already know that stuff before it gets to the server. And that's also going to help your metrics for your time to first interactive is going to be a lot quicker. Your time to first, contentful paint is going to be better as well because the data is already there in the HTML. We're not waiting for the JavaScript later to be loaded. We're not waiting for that API call to be made after the page is loaded. We've already got that in there for you. So how does that all look? Well, all right, we're going to try to do a demo here. So let's see what happens. Let me just switch over here to the screen. All right, so I have already created a sample enhanced application, and I've done that because nobody wants to see npm install running. That's not a good use of your time. In the enhanced application, we have a couple of things. Under the app folder, we have our APIs, our elements, our models, and our pages. So basically, anytime that you hit a page, for instance, the conferences page, it will look for a corresponding API to call as well. So it will call the conferences API route, get the data for you, pass it on to your page, which can then be used in your elements, which are part of your page. I think really the best way to show this kind of stuff is to start with building up a page. All right, so let's just start with, let's call it about.html. And so we have our brand new page here. Now let me just grab some code from the other side of my screen because I am one of the world's worst typers. I will spend, I think, 33% of my time hitting the backspace key. So, all right. So we're just going to have this HTML fragment. We have a section, we have a header one, we've got about me, and then we've got this custom element called social link. So if we take a look at that in the browser, we go to our about page. We can see that we have that title is there. And if we open up that section, we can see there is social links. So, hey, the browser knows that there's a custom element, but since there's no definition for it, it's just not showing anything at all. All right, so let's fix that. We're going to go over into our elements folder, and we're going to create a new file. And let's see how I can't type. Let's call it social links MJS. And one of the things to note here is that your custom element should have a dash in it. Basically, the way that web components work is you can't give it a one-word name because that could conflict with the tags that are already registered in the browser. So that is a requirement when you're naming your tags. All right, so I'm just gonna copy in this pure cloud function here. What is happening is when this function gets called, we're going to take a look in our state to grab our store, in our store to grab our socials, and then we have an unordered list, and we're just going to map through that unordered list, printing out some list items with all of the different socials that we have programmed. So if we refresh the page right now, you will see that, oh, okay, social links, which used to be completely empty, has an unordered list tag in it because what's coming down from the browser is already expanded for us. Well, that's great. So even if JavaScript wasn't working, we'd still be able to see our social links. But the problem that we have right now is we have no data. So if we flip over to our API folder and we create a new one called about.mjs, so this is our API route that is going to be run when we hit the about.html page. And in this case, we can use any of the verbs that we want to. Since we're going to be getting the page, we'll use the get verb, but we support post, put, patch, delete, etc. For your API routes as well. So we are just going to return some JSON. I'm going to have a socials array, which has all of my different socials. And if I go back over here, the hot reload has already taken care of it. So our unordered list is populated with all of the different LIs, which is all of the different places you can find me on the interwebs. So not super sexy, but it works. And, the nice thing is this, if I, turn off JavaScript here and I refresh that page, it still works because all of that data is coming down from the server already. It won't break. One of the other fun bits that would mention, if we go into our social links side of things, We can also add some styling in here as well. And I am terrible at CSS, so I'm going to do something like incredibly ugly. So for our, let's see, for our unordered list component, let's just make the background color red, because I am terrible at CSS. And there we go. One of the things that you'll notice with Enhance is that we are hoisting those styles up to the header for you. No, that's our default Enhance styles. Yeah. Where is my styles? Yeah. Oh, sorry, it's right here. It was already expanded. So our social links component, anytime there's a UL in it, make the background color red. So you're able to start building up your components using HTML, CSS, and JavaScript kind of in this single file component type of thing. And we will worry about hoisting your CSS into the head so that it can be used, and also any kind of JavaScript that you add in there as well. The other thing that we should take a look at is something I've run before this talk, and then this is this conferences thing. So I have this conference coming up in Montreal. It's called Confu, and that's the date. But I realized that, oh yeah, I should probably add this conference in as well. So let's just put in the jam dev, and let's see, it's today. And there we go. All right, so we have these things in, and basically what's happening is using Enhance, we have run the scaffold generator, which is a lot like, what you would see in Ruby on Rails. And we've created this, CRUDL interface for you so that you can create, read, update, delete, list your objects. And we're having all of this into a backend database. And in this case, we're using DynamoDB in order to store all of this data. So I'm like, oh, actually, the date on Confu is wrong. So let me just go ahead and, whoops, I'll just change that to my presentation's on the 22nd. So it's all well and good. And then, of course, if we turn off JavaScript, the page still loads. And, let's just get rid of the jam dev because, we're already doing that talk today. And there you go. You have, working HTML that can be progressively enhanced to add more functionality to it. But in a lot of cases, you may find that you don't even need to progressively enhance these things. In a lot of cases, especially if you're working for a large multinational corporation and you need to do these kind of one-off things, you may want something like this instead of having to get into way, way, way more complicated code. All right, let me turn JavaScript back on before I break everything else in my browser. All right. All right, now, some of the key concepts around Enhance is that, we have file-based routing. So anything that you put into that pages folder and you can nest it as deeply as you want to, that will show up as a page in our Enhance application. Any kind of reusable components you want can be done using custom elements, using your web components. We have this built-in CSS utility class thing called Enhanced Styles. You can use it. You can pull in your own type of CSS if you want, or you can even add Tailwind in, but we give you a default way of doing utility-based CSS to start with. I know that is a topic that not everybody loves. And then, of course, the API route that I showed you, you don't have to worry about passing in these props to every component. Anything that is at that route, in this case, we use the About page. So anything that is in the About page, all of the child elements to it would get all of the props in the store. So they'd be able to pull it off there. You don't have to worry about doing any kind of crazy prop drilling or manually wiring of these things. And then, of course, all of this is done using progressive enhancement and standard JavaScript. There's no special syntax. If you are going to do some in client-side JavaScript for things, you would just end up adding a script tag into what you send down to the client, and that's where you would instantiate your web component on the client side, and register your event listeners and do all your other normal JavaScript stuff. And underneath the hood, we're using Architect to deploy this thing. We're using AWS to run your cloud functions, DynamoDB in order to be able to do your database. So it's a fully functional web app. So it has your infrastructure as code. It has your cloud database that is completely managed. Everything is pretty much being done for you. So with enhanced.dev, we're doing a pretty good job of bringing together both the front end and the back end. They can really agree upon things in this situation. Now, if you want some more information on this, I think the best thing to do is to check out Enhance. You can read the docs at enhance.dev/docs. You can join our Discord and ask us questions. We're happy to hear from them. And of course, follow us on Mastodon, not Twitter, because it's a terrible cesspool now. So anyway, that's pretty much where I've got on this talk. So, please let me know what questions you've got.
Thanks, Simon. I love that presentation. I have so many questions, and we really only have a few minutes. And so just a reminder to you folks in the audience, if you do have a question, click that add a question link at the bottom of your screen, add your question there, and we will try to get to it in the next few minutes. Now, I've got this long list, so I'm going to jump right in. So at JamDev, we're often talking about Jamstack and different trends in Jamstack, and I know that folks are generally we're still holding on in some ways to the more traditional static site generators, but we're seeing more server-side rendered content. And so I imagine a lot of folks are watching your presentation and thinking, is it like exclusively SSR? Or do you have the option to pre-render content with Enhance? Is that in the works, or are you solely focused on the server?
Yeah, we're exclusively focused on the server-side rendering piece. One of the things that I neglected to show is that there is a public bucket, which basically ends up mapping to an S3 bucket. So if you wanted to run a process outside of Enhance that would populate that bucket with your static site generated content, you can definitely do that. One of the traditional things that I've seen people use Jamstack for is reading a bunch of markdown files and converting them into HTML and storing that in your bucket. We've had a lot of success with actually just automatically generating that HTML on the fly. It does not take very long at all. Enhance.dev itself is done using that, all of the documentation. It's an open source project. You can see how we did it. We've written articles on it before as well. There's not really a performance penalty on that. And one of the nice things about rendering things this way is that if you have to insert any kind of dynamic content or personalization based upon the user that's logged in, you can query that on the server side and send it down the wire with the initial page load and not have to wait for another API call to be done after the fact. And that's kind of where this stuff fits into the new definition of Jamstack, because there's no one right way to do it anymore, eh?
Exactly. So I imagine that you're going to be able to use this in conjunction with Begin, but what about a lot of those other cloud providers? Can you pretty much deploy an Enhanced application anywhere?
Right now, the Enhanced applications are deployable to AWS. It's based upon Architect is the underlying functionality for it. So we're going to give you the best experience possible on Begin to be able to deploy to our infrastructure. But if you do not feel like using Begin, you can use Architect to deploy directly to AWS. And of course, if you are really feeling like you want to manage it all yourself, you can eject from Architect and deploy directly to AWS as well. In that case, you've got to manage a lot of cloud formation stuff yourself, and I do not recommend that. You definitely want to use a tool to do your infrastructure as code, because 10 lines in an Architect file where you have maybe 5 API calls, a static bucket, ends up being 1,400 lines of cloud formation, and you don't want to write that. That's just terrible.
Yeah, a case where using the abstraction layer, totally okay, right?
Yeah, exactly.
Okay, so I also noticed that there were a handful of MJS files in the project, and I know this is very polarizing topic, but curious about your opinion and Enhance's opinion on TypeScript. Is that something that you have native support for? Do you feel like that kind of goes against the idea of getting back to the basics using native libraries, et cetera?
Yeah, I'm not personally a fan of TypeScript. You can use TypeScript with enhance and begin, but you're basically adding a transpilation step to your code. So the TypeScript code that you write is not the JavaScript code that gets executed on your browser, and we're trying to stay away from that. It makes it more difficult to debug. I know that people love a lot of TypeScript's functionality. I'm very excited about one of the proposals at TC39, which is to add types to JavaScript, at least in order to be able to say that in this method signature, this ID is a GUID, and this is a string, and this is an integer, so that that kind of static type checking can be done at development time, and it just disappears at runtime. And so you don't have to worry about doing all the transpilation and stuff like that.
That makes sense. Yeah, yeah. Now, in the chat a little while ago, we had a message looking back here from Henri, and he mentioned that he profiled it's the CBS Sports website, and said that they're currently running jQuery version 1.8.3, which was launched all the way back in November 2012. And I really loved the beginning of your talk, where you had the quote from Jeff Bezos on, what isn't going to change in the next 10 years, and getting back to, what really focusing on what is going to be stable. And so I'm just curious, kind of from a general perspective, do you see it as bad practice to use old libraries? Like if jQuery still works, is that okay to still use? How do we balance that with all the new shiny stuff that's coming out?
Yeah, I don't have any problem with using jQuery. My recommendation in that particular case would be to stop using it, because a lot of the things that were in jQuery have ended up in the platform. So you can reduce the amount of JavaScript that you send to your client by using the platform directly. And that's kind of one of my arguments with a lot of the other UI frameworks, is that they were around when we didn't really have a good component model in the browser. But now that we do, they should be starting to remove some of their complexity in favor of web components. But we're really not seeing that right now. So we'll see what happens. But the nice thing is, like, if you started a business 10 years ago building WordPress and using jQuery, you're still making a lot of money doing that right now. It may not be sexy. It may not be the most technically difficult thing, but you're still making a living on it because the platform isn't breaking on you. And if you started 5 years ago or 7 years ago using React, and you decided that you went from create element to JSX to hooks to whatever is the new thing, like every 18 months or so, React kind of reinvents itself, and you're chasing those changes nonstop. And you have to ask yourself, did I just waste a lot of time that I could have been, building functionality for my customers and making money, instead of just chasing these unplanned outages? Anyway, I try not to slag on React too much. I used it for many years, but I think I have seen the light.
Yes, totally fair. Totally fair. Now, there are mixed opinions on this, but you mentioned web components had their 10th birthday already. And I felt like there was a lot of noise in the first couple years, and then kind of fell off for a while. React got super popular, and really still is, but really within the last 6 to 12 months, personally, I have seen a lot more noise around web components in this space. And I know that you're betting on it. I think I'm curious on your perspective of, so you're seeing some trend that, I guess what I'm trying to ask is, are you seeing this approach resonate with folks? Do you feel like we're going to start to see some other frameworks pop up as well? Like, is this a trend that we're seeing, kind of getting back to the basics?
I totally believe that. I mean, we see things like not just Enhance, but Astro 11D with WebC also using web components. You've got major companies like Google has built YouTube using web components. Adobe has built all of their Creative Cloud web stuff using web components. I mean, it's kind of ready for prime time right now. When it was initially, the problem is, when it was initially announced, it was a spec that was still evolving and it wasn't quite ready yet. And when it comes to the evolution of specs, it takes a while before these things actually solidify and get all of the use cases. That's where client-side libraries are super useful because they're able to iterate rather quickly. So jQuery is an example. It iterated quickly and eventually those things added up in the platform. PhoneGap, Apache Cordova on the mobile side, they implemented a bunch of the APIs for like connecting to the camera and other mobile APIs that eventually made their way into the platform. And why aren't some of the things that React and Vue and Angular are done migrating into the platform or being replaced with what the platform already has available, and that's web components. So I think you'll see a lot of people starting to switch in that direction.
That makes a lot of sense. Yeah, I'm going to keep an eye on it because this is, I love the concept of getting back to the basics, using native libraries, and I'm really excited for what you've got going on at Enhance. Now, one last kind of off-topic question from the audience before we wrap up. It's from Brian and says, when will the Habs finally win another Stanley Cup?
I feel like, and I know this is coming from Brian LaRue, so the Habs will defeat the hapless Vancouver Canucks in 2027. That's my rock solid guarantee.
Okay, that's the prediction for you folks. So yeah, keep an eye.
I can't back that up.
That's all right. I love it. Hey,